Dear students, now in this video we are going to discuss about the turbines, Francis turbine. Okay, in the previous video we have seen about this Pelton turbine, which is a tangential flow turbine, and what do you mean by a turbine, what are the classification of turbines, all the things we have discussed. Now in this case, Francis turbine, how it is different from the Pelton wheel turbine, and according to the classification, in this it will come under which category it will come, all the things we are going to discuss now. So first of all, Francis turbine, how it is generated and who is that inventor is, we can see James B. Francis, an American civil engineer, decided this type of turbine. So on his name it's called as Francis turbine. And this turbine, which uses both the kinetic and the potential energy for producing the electricity. Actually, the turbines are used for converting the hydraulic energy or fluid, any fluids, it may be a steam and maybe or whatever the energy which is coming through the fluid, that is to be converted into a mechanical energy, that is a rotary energy. So it depends upon the actually the Francis turbine is used for the conversion of water head. What is the potential energy and the kinetic energy which is created by the water flows. Okay, it converts into a rotary energy. That's what the main intention of the turbine. So here what happens is the flow rates may be as low as 10 meter cube per second to 700 meter cube per second. Okay, the water flows from the dam or reservoir. It have height of 50 to 100 400 meters. There only we can use this type of Francis turbine. So here the level of water which comes through the pipe and penstock or any the pipe, it enters into the turbine through a spiral casing. So the casing is very important here. The casing consists of the blades, and the guide blades, runner blades and stay blades will be there. So let me see one by one. By seeing this sketch, we can see the top view of the Francis turbine and the front cross-sectional view. So this top view, you can see this a spiral casing where the size of the casing is going continuously, also decreasing in a smoother way. There we will have the guide vanes which is attached on the periphery of the runner, this one. So when a runner is actually, it is used for the rotation of the shaft. Okay, when the water enters in the turbine, it will goes spirally inside and it makes the runner to rotate. Okay, after that it will go for the tail race. One by one we will see here what is this, and this in this view we can easily comes to know that the spiral casing, how it will looking like, and where the stay vanes and the guide vanes which is there located, and through which the guide vanes are guiding the water into the runner beds, right? So here part by part, if you see that spiral casing. So what is the spiral casing? A casing in the sense it covers all the parts of the turbine blades, turbine shaft, runners, runner vane, guide vanes, stay vanes, all the things will be covered. And the spiral casing, it is made up of cast iron, and it doesn't allow the water to flow outside. That's it. A splashing of water can be prevented, and the uniform decreasing cross section of this spiral casing will be used for the uniform velocity flow of water. Okay, so when it enters striking the runner blades through the guide vanes, it will go inside, and the flow rate would be decreases when it is along the casing, when travels along the casing. So we reduces the cross section of the casing to make the pressure uniform and to make the momentum uniform. So the velocity after it gets guided by the guide vanes, it strikes on the runner blades, the velocity will be uniform, right? So this is the function of the casing over here. And the second one is the stay vanes. Okay, The stay vanes and the guide vanes are very important. So the runner vanes are connected with the shaft which is going to be rotated over to the runner blade. This apart it make the fins like structure, the stay vanes and gate vanes are allowing these or remains allow the water to flow radially inside. So the stay vanes are stationary vanes, and it reduces the swilling effect of water due to the radial flow. Okay, well, normally we know water when come water will come radially inward, so it will make the swirling effect. To avoid that one, the stay vanes are there, and then the guide vanes which allows the water to flow into the over the runner blades. The guide vanes, we can adjust the vanes. There is a possibility of changing the air angle. So the changing the air angle, why it is used, no, it is used to control or regulate the flow of water into the runner blades. So the can control the angle of attack when water is guided to the runner blade. This guide blades or guiding the water to hit on the blade on what flow it is to be required, what rate of flow and what direction it has to flow. All the things can be adjusted, the angle can be adjusted, the rate of flow mainly it will be used for how much water is required for rotating. So that power output depends upon the output power required. If I require more power, then the guide vanes or tilted to allow more water. If I require only less power, then the guide vanes are to be closed in a way that it will allow less water to flow. And next, after the guide vanes only, the water gets entered and the water gets hit on the runner blade. The runner blades only decide how well a turbine has to rotate or has to perform. So the runner blades of a mixer flow turbine can be divided into two parts. One is upper part of the blade using reaction force, and second one is the impulse force. So the reaction force, normally this is called the reaction force turbine. These two forces together makes the runner to rotate. Okay, one is impulsive force, another one is the reaction force. The reaction force, the blade itself, it will make just like a nozzle. Here there is no separate nozzle present as in the case of Pelton wheel turbine. The blades itself, it acts as a nozzle, and to the when water flows through that blades, it will create the back reaction on the blades. So continuously it really is going to be rotated. And after that, when it hits on the turbine blade and rotates the blade, then the water it is going to be we have to remove the water from the area. So the water coming out of the runner blade will be having a low pressure. Normally it will be at a low pressure. To make it a considerable pressure, then we have to increase towards the pressure towards the tail race. So there the draft tube, which is an increasing cross section, just like what we call it as extension, or there's a when the diameter of the draft tube is enlarged, so there the cross is getting increases, the cross section is getting increases. So water pressure will be maintained, the recovering of pressure may be possible. So it will avoid the back pressure and cavitation creation, all the unwanted damages to the turbine blades, right? So here you can see the draft tube, which where is an increase in cross section, and it will goes to the tail race. It is connected to the tail race where the water gets joined with this river tail race, or where the water has to dispose. So first the decreasing of cross section of the spiral case, pressure energy would remains uniform. It will make sure that, and after this it rotates the runner blade. It through the gate vanes and stay vanes it moves. The stay vanes is going to remove the swirl effect of the water, and then it goes along with the guide vanes. The guide vanes is controlling the flow of water, which is required, the control of water, how much is required, it will do it. So the runner blades and the sternwards stay blades, which guide the water to get into the runner blade. The stay vanes and the guide blades make the water to enter, and after that the draft tube, which is having increasing cross section, which will guide the water to go to the tail race by maintaining the regular pressure. So this is what the Francis turbine works, and the application is normally used in the hydropower plants and mixed flow turbines for the irrigation water pumping system. So it is the most efficient hydraulic turbine which is used, and in the next video we are going to see about the Kaplan turbine. Okay, so the efficient water head flow rate will be there in this Francis turbine. Okay, let me see the Kaplan turbine in the next video.